Hello students, a very good morning. So Ayush, good morning. Falan Grenade, good morning. Ashmit, good morning. Sanjay Kumaran, good morning. Ankita Yadav, good morning. Kanak Gavel, good morning. Sanjay, a very good morning. Deepshika, good morning. Yes, students. So we are here back with our energies today, energy and enthusiasm. Let's take on complex number in our stride. Okay, so here at Careers 360, we have a mega revision marathon for you guys. Actually, in this difficult time of lockdown, where we realize that your studies are affected because of lack of offline coaching, we here at Careers 360, we have brought in an online mega revision marathon for JEE Main 2020. So, here we plan to assist you in your POA. Okay, we don't want to revamp your preparation, but we want to assist you. That's all what we have in aim. So, yes, all set to go? Yes, Snigdha, Minakshi, Senthil, Tarun, Prabir, a very good morning. Ayush, you got 6-7 questions right out of 10 in mock. That's good. That's really good. Okay, so let's move on to complex numbers. Students, we'll be doing complex numbers today and we'll be taking on quadratic equation tomorrow. Complex number is one of the superb and difficult topic of IIT JEE. So as of today, we'll consider only complex numbers. Okay, so let's start complex number. Yes, Madhu, Ronak, good morning. Asa Gupta, you are saying, is it enough for JEE Advance? What actually you are saying for JEE Advance? My lecture. I say that it will assist you. It will set the tone. Okay? Prince Raj Arya, good morning. Krishnaveni, good morning. So let's go to the roots of this equation. What do you think, students? What are the roots of this equation? So we go with the very basic. We know we have to solve it like x square is equal to minus 1 or x is equal to under root minus 1. Am I right? So under root minus 1 is something which is known as iota. Acha, by the way, am I getting only iota or what? In fact, it is plus minus iota, hai na? So this is what we get. So iota is something which is defined as under root minus 1. Okay. So then we go on to the next CD. Next slide, integral powers of iota. Is this complex number chapter appears in CT? Yes, complex numbers appears in CT. Madhu Chetna. Good morning, Rishabh. Prakash Aniket, good morning. Okay, what is iota? Iota is under root minus 1. We represent it by I. So now here we talk about integral powers of iota. Okay, so let's say we have iota as under root minus 1. So this implies iota square would be minus 1. Am I right or wrong? Then simply iota cube would be iota square into iota, that is minus iota. And iota raised to the power 4 would be iota square into iota square, that is minus 1 into minus 1, that is 1. Am I right, students? So for that matter, we realize that any multiple of 4, iota raised to the power 4n, where n belongs to integers, is equal to 1. You can remember this. Okay, iota raised to the power 4n is 1. So can you do this question? We have n is equal to, this is n 1 to 13, and we have iota raised to power n plus iota raised to power n plus 1. Can you answer me what is this? Yes, Ayush, we'll have a lot of questions in between them. Okay. So n is 1 to 13. So I'll rub it off. I made a little bit of mess here. So I'll rub it off. And the students, those of you who got this can check this question out. N is equal to 1 to 13. That's what I intend to write. N is equal to 1 to 13. Can somebody give me the answer? So when we'll add this up, I mean iota raised to power n can be taken common. Isn't that right? Sigma, I'll have 1 plus iota. Oh, sorry, iota raised to power n would be inside only. So 1 plus iota is a constant. I can take it outside, and sigma iota raised to power n is equal to 1 to 13. Anna? So Madhu, you are giving me -1 as answer. Kanagavel 0. Deepshikha -1. So 1 plus iota is a constant. I can take outside the sigma. This would be 1 plus iota. And please understand, 4 consecutive powers of iota add up to 0. I mean iota raised to power 1, iota square, iota cube, and iota 4. This adds up to 0. 4 consecutive powers, if given in addition, that gives you 0. So till 12 it will give me 0. Okay. So what do I have? Till n is equal to 1 to 12, I'll get the sum as 0. So iota raised to power 13 would be left. Okay. So iota raised to power 13 is what? Iota. Because you'll divide it by 4. Whatever is the remainder, that is the power of iota. So 1 plus iota into iota. Is that okay? So what do I get? Iota into iota, that's iota square, that's -1 iota. So iota -1 we'll get as our answer. Okay, students? Yes, Deepshikha, your answer is correct. Hasita, your answer is correct. So I hope you understood this question, students. We have to understand that any powers of iota, we divide it by 4. Whatever is the remainder, that is the power to the iota we get as a result. Okay. So now let us, this is the Sudha Shri. No, only first topic we have done the integral powers of iota. That's the only thing we have done, Sudha. So what is a complex number? Let's see. A complex number is the sum of a real number. Okay. It is a sum of a real number and an imaginary number. So what do we call as an imaginary number? Any number, any multiple of iota. Integral or... Yeah, so the Jatin Raj generally attend the classes. He always is present. I think I am not pretty sure whether he is there or not at present. Sum of a real number and an imaginary number. And complex number is expressed in the form of a plus iota b, where a is the real part and we define it by Re and b is the imaginary part. Okay, you are all aware of this. So here we have two important concepts coming up here. What? Number one, I mean complex number is represented by z, that is a plus iota b. So one thing we have to understand is z plus z conjugate. Acha, conjugate I'll tell you a little later. Okay, Sudha, you are Jatin Raj only. Okay, by the name of Sudha. So z plus z conjugate is twice real part of z, है ना? And second, z minus z conjugate is twice iota imaginary part of z. When I say real part of z, I mean a. When I say imaginary part of z, I mean b. Okay? So that's what I wanted to express it here. Second thing which I wanted to tell you was that can you tell me that is complex number, does complex number follow the property of order? Orderness property is there? Tell me. Orderness property is there. Can I say that 2 iota is greater than 3 iota? Or 3 iota is greater than 2 iota? Can I write like this? Say yes or no. Is this a correct statement? Hello? 3 iota is greater than 2. Yes or no? Tell me. So I'm waiting for your answers, students. Or 7 plus 8 iota is greater than. Yes, everybody said it. No. Kanagavel, yes, you are saying. Ronak, no. Mansal, Ranjan, no. Okay, very good. It is no only. Because iota do not measure anything. So, if they don't measure anything, how can any imaginary number be greater or lesser than the other? Okay, so that's why this inequation has no meaning. I hope all of you understands this. So let's move on to the next slide. Okay, let's move on to the next slide. Acha, before moving on to the next slide, I would like to give you one more question. Okay, yes, students, there is an inequality. There's an inequality, you can write it down. That is mod of z minus 4 is less than mod of z minus 2. Modulus of a complex number is real part square plus imaginary part square. I'll be moving in and out of the topic. Imaginary part square, that is mod of z. Anna, what does this represent? Can somebody tell me what is the region represented by it? What is the region represented by it? Tell me. I'll take up modulus of a complex number a little later, but here it is to suffice that mod of z is real part square plus imaginary part square. Okay? Can somebody tell me what does this region represents? Okay. I'm waiting for the answer. So, whenever we have an equation like this, z minus 4 is less than z minus 2. Interior of a circle, no, it doesn't represent an interior of a circle. Now, whenever such an equation, because you will get a lot of equations in locus, okay? No, it's not a circle. I'll come back to this slide again a little later. Okay, let's move on ahead. You keep on thinking and let's see when I teach you, you get the concepts all right. Okay, so we discuss Meenakshi Sundaram parabola. No, it's not a parabola. The conjugate of a complex number. What is a conjugate of a complex number? We'll come back to that slide once again. Okay, conjugate of a complex number. Suppose z is 2 comma 2, that is 2 plus 2 iota. Okay, then conjugate of a complex number is the reflection of the complex number in real axis. That means that would be 2 minus 2 iota. Okay, that is a conjugate of a complex number. Suppose z is a plus iota b, then conjugate of a complex number is represented by z bar, and that is a minus iota b. We multiply the imaginary part by minus. Prashant, I'll explain. Just wait, I'll come back to that slide once again. So this is a conjugate of a complex number. Conjugate of z. Okay. 2 minus 2 iota. That's perfect. So that's a conjugate of a complex number. Now, let us talk about the other slide. Let's see what properties conjugate of a complex number has. Okay. We have z conjugate. I mean, realize conjugate of a conjugate is z. Then z plus z conjugate is twice real part of z, that I already expressed. And z minus z conjugate is 2 iota. Iota also is there. 2 iota imaginary part of z. A slight mistake in this representation. 2 iota imaginary part of z. Okay. When I say imaginary part of z, region rightward x equal to 3. Okay, you mean to say real part greater than 3. Okay, you keep thinking. Yes, Gyanvi. Yes. Okay. So, this is z minus z conjugate. Z plus z conjugate means Z minus Z conjugate, Z is purely imaginary. I mean, this is the condition for purely imaginary. Okay, what's that? That the real part is 0. When I say Z plus Z conjugate is 0, I mean real part of Z is 0. This would imply Z is purely imaginary. When I say purely imaginary, I mean a number like 2 iota, 3 iota, 17 iota. Okay. Now Z minus Z conjugate is 0. That means Z is equal to Z conjugate. Z is purely real. Okay, this again is very important. Later on we'll be using all these concepts. So when I get this as 0, I basically mean imaginary part is 0. So this implies Z is purely real. Okay, so what do we realize here? All real numbers are subset of complex numbers. Hana? Complex number is the actual big thing. Okay, what else do we have? What else do we have in conjugate of a complex number? We have Z1 plus minus Z2 whole conjugate. When I say whole conjugate, I mean first of all I'll solve Z1 plus minus Z2 and then I'll take real part minus iota imaginary part. Okay, so this is equal to if you separately take their conjugates and then add. Okay, students, and in general we can have such for many complex numbers. This is the result. Previous inequality question, you are saying answer is region leftward x equal to 3. Okay, I'll check it. We'll come back to that question. Why to disclose the result right now, Hannah? Then we have Z1 into Z2 whole conjugate that I can separately take their conjugates. That's the result for all complex numbers. I mean, for so many complex numbers, we have this result. This all is very useful, students. You should remember these properties. And then we have for the division as well. It means Z1 by Z2 has to be done first and then we take its conjugate. And here we take the conjugate separately, numerator and denominator. Now this is another important property. Z raised to power n whole conjugate is Z conjugate raised to power n. I mean, whether you take conjugate and then do the power n or power n and then you take the conjugate, they both are equal. Seventh one, once again, seventh. Beta, it is Z1 into Z2. Okay, Madhu? Z1 into Z2 when we do, we first of all calculate Z1 into Z2. Multiplication of complex number. I hope you are comfortable with multiplication of complex number. Like, suppose you have 2 plus 3 iota into 2 minus iota. And whole conjugate is given. So, this is equal to, if you separately take 2 plus iota conjugate, and if you separately take 2 minus iota conjugate and then multiply, then I can do like that. So 2 plus iota conjugate would be 2 plus 3 iota, I mean 2 minus 3 iota, and 2 minus iota conjugate would be 2 plus iota. So this would be equal to this. Here on the left hand side, basically it means first of all I need to multiply this and then write it. Like for example, when I multiply this is 2 to the 4 and plus 3, 7. And 2 minus 2 and 6, that is 4 iota, and then take its conjugate. This would be same as this. Okay, eighth one, once again, eighth is that Z1 upon Z2, we first write Z1 upon Z2 in modulus A plus iota B form. Once I have written this in A plus iota B form, then I take its conjugate. That is the left hand side. Okay, this is equal to conjugate of the numerator upon conjugate of the denominator. Am I right? Yes. So this way we have done the properties of conjugate. Then let us come to, yes Madhu, my pleasure beta. Then we have modulus of a complex number. What is the modulus of a complex number? For that matter, modulus of any number itself. It is the distance of that number when plotted on the graph from the origin. That is what the modulus means. Okay, the modulus of z denoted by mod z is defined to be non-negative real number. This is the value we get, real part is square. I mean, it's better to remember by this. So Jatin, you are saying 10th one. 10th one was what? I'll come back to it. So it is real part of z, that's whole square, plus imaginary part of z whole square. Okay, that's the modulus of a complex number. So if this is x plus iota y, which is represented in Argand diagram, I hope you remember that the diagram, the graph in which we represent a complex number, it is Argand diagram. Okay, so here I have drawn an Argand diagram. I'll come back to it. So mod z is, this is mod z, that's how I represent. That's the distance of the complex number from origin. So if this is the y coordinate, this is the x coordinate, mod of z would be under root x square plus y square. Am I right? Prashant, you are saying negative number also output positive, sir. I didn't get you, beta. And I'm coming back to the previous slide. 10th one. 10th one, I forgot to explain. You're right only. So, what is that? We write it z1 plus z1 into z2 conjugate plus z1 conjugate into z2 is twice real part of z1 into z2. How do I get this? So how do I get this? I write z1 into z2 conjugate. Now please focus, students. Now the second thing, how will I write? I write z1 into z2 conjugate and whole conjugate. Am I right? Can I write this second bracket like this? Because when this conjugate will percolate down, it would be conjugate upon conjugate. Z2 would remain without a conjugate and it will become Z1 conjugate. Now this is a complex number. This is its conjugate. This would be twice real part of the complex number itself. Am I right? Z plus Z conjugate is twice real part of Z. I hope you got this. Yes, students. Is it okay, Madhu? 10th one I have explained now. Okay. Now I move on further. These are the simple, till here you have studied in 11th. Then we talk about properties of modulus. Okay. Modulus of a complex number. What do we have? We have mod of z is equal to mod of z conjugate is equal to mod of minus z conjugate, mod of minus z conjugate. Okay, they all are equal. Yes, Jatin, my pleasure, beta. Z conjugate is mod z square. Okay, this is most important property. Please remember it. Then mod of z1 z2 conjugate, modulus is mod z1 into mod z2. I can separately take their mods. Then z1 plus minus z2 whole mod is less than equal to mod z1 plus mod z2. Now these two are known as triangular inequalities. What are these known as? Triangular inequalities. Why they are known as triangular inequalities? We consider, yes, Mala Jaswal, hello. Meenakshi, my name is Parth Rastogi. Okay, so we have z1 plus minus z2 whole modulus is less than equal to mod z1 plus mod z2. Actually, z1 can always be represented as vectors. Okay, so suppose this is z1, this is z2, then I complete the third, triangle law vectors I'll make use of. This is z1 plus z2. Am I right? Now, every time, this length would be mod z1, this length would be mod z2, this length would be mod z1 plus z2. Okay? Now, in any triangle, the sum of two sides is greater than the third side. That's what here it is depicted. Sum of two sides is greater than equal to the third side. If I take z1 minus z2, it would be the other diagonal of the parallelogram. Okay? So, that's how we get it. And equality sign, when origin z1 and z2 are collinear, that's when we get the equality sign. Okay. Similarly, any side is greater than the difference of two sides. That's where we get the complex where we get this inequality. Okay, this is also very useful. Rekha Rostagi, pleasure. I accept your thanks. Z raised to power n whole modulus is mod z raised to power n. It's a useful property, students. Okay, we do one question immediately. Can somebody tell me? I mean, it's a quick question, almost like NCERT miscellaneous. 1 plus iota into 1 plus 2 iota based on properties itself. 1 plus 3 iota, okay, and so on till 1 plus n iota. That's equal to alpha plus iota beta. Okay, that's given to us. Now, I want to find what is the value of 2 into 5 into 10, okay, 2 into 5 into 10 and so on into 1 plus n square. Can somebody tell me what is its value? Anupma Rai, good morning, a very good morning. Yes, Prashant, my pleasure, beta. So what is this value equal to? Into, there's an into sign. So anybody giving me an answer? So this is, I take mod both side, I take mod both side. Then I make use of this property, third property. I'll separate out the mods. Okay, I'll separate out the mods at the left hand side. And then I do squaring both sides. Okay. So 1 plus iota mod square would be, no Tarun, it is not n into n plus 1 by 2. Sanjay Kumaran, a square plus b square, that's perfect. Alpha square plus beta square. So 1 square plus 1 square, that is 2, the mod of 1 plus iota whole square. 1 plus 2 iota mod square would be 5. 1 plus 3 iota mod square would be 10. So left hand side represents this. And this would be right hand side modulus square, that is alpha square plus beta square. I hope it is okay. Yes, Sanjay, thank you. Yes, Meenakshi, you're right only. So we have done it. We go to the next slide. I hope students you understand it. Anybody having a problem in this? Yes, Kanagavel, you're right only. We move on to the serious things now. Now, argument of a complex number. What is an argument of a complex number? Argument of a complex number actually is, for example, if we, I mean, there are two things to be explained. One is argument and one is amplitude. Okay. Amplitude. You guys must be getting confused between amplitude and argument. Sometimes we use argument, sometimes we use amplitude. I know. Now, whenever z is plotted on an Argand diagram, that is z is equal to x plus iota y. Whatever is its inclination with the x-axis, whatever that theta is, that tan theta is the argument of the amplitude of the complex number. No, these are not same thing, Ayush. So whenever theta lies between minus pi and pi, it implies we are talking about the amplitude of the complex number. Okay, or principal argument we are talking of. Principal argument. Otherwise, it is argument. I mean, any angle beyond this interval will be understood as an argument. Okay, so if somebody says argument of a complex number is 390 degrees, so we are referring to its argument. Any angle outside is known as argument. Okay, I hope you understand. Tan inverse of y by x, absolutely right. So tan theta is y by x, है ना? So argument would be, argument of z is theta only. Okay, that is tan inverse y by x. Okay, but that is the principal argument or the amplitude. Only when the complex number is represented in the first quadrant, then only this is defined like this. Okay, otherwise it is not defined like this. No Mercy, good morning. My cold is all right. Student, thank you for asking. So let's check it out. What is argument of a complex number? We'll discuss a little more. Okay. Let's consider an example. Let's see. Suppose a complex number is like a complex number is here in the third quadrant. Okay. It is minus 1 minus root 3 iota. Okay. Suppose this the complex number is this. Okay. Now, if the complex number lies in the third quadrant, then we calculate the argument differently. Okay. The formula which was given to you earlier, that is tan inverse y by x, that is only for the first quadrant complex numbers. Okay. For here, we'll calculate in a different way. Okay. Yeah, minus pi minus theta. You're right only. We'll calculate theta here. Theta would be tan inverse modulus of y by x. I'll consider theta like this. Rekha Rustagi, previous slide explain. What particular part of the previous slide you want me to explain? Just a moment. So tan inverse y by x. So what is y here? Y is minus 1. What is x here? Minus root 3. Sorry, the other way around. Minus root 3 and minus 1. Okay. Now for third quadrant, theta would be tan inverse, what's that? Mod of y. What is y? Minus 3. I have made a little bit of mess here. I'll clear it up. Okay. Yes, students. So we have this y as minus root 3. This x is minus 1. So what is that? Minus root 3 upon minus 1. What do I get? Root 3. Tan inverse root 3. Tan inverse root 3 is what? Tell me. Tan inverse root 3 is pi by 3. Okay. Now, when I get this, actually in the third quadrant, if the complex number is lying in the third quadrant, I define argument as theta minus pi. Okay, that's how I define theta. Theta minus pi. So I'm getting pi by 3 minus pi. So the argument would be minus 2 pi by 3. Okay, I'll give you the whole details of this a little later. Definition of argument. Definition of argument is when a complex number is represented on an Argand diagram, the angle which the line segment makes, the line segment joining the origin to that complex number makes with the x-axis, positive direction of x-axis, that is known as an argument. Okay, I hope I have defined it. So this is minus 2 pi. This is the argument of this complex number. Okay, which complex number? Minus 1 minus root 3 iota. Okay, I'll give you for all the cases. Minus 2 pi by 3. Yes, you're right, Ayush. In just next slide, I'll explain you. So here we are. Or I'll explain you in this slide itself. Just a moment. I'll again redraw. Okay. So just a moment, students. I'm talking about the argument of a complex number. How we'll find out argument of a complex number. Okay. So how do we do this? We write the complex number. We define an angle alpha. Okay. Now I'm giving you the method how to find the argument of a complex number. Okay. So this is y-axis, let us say this is x-axis. Okay. Here in Argand diagram, this is known as real axis and this one is known as imaginary axis. Okay. Now, what do we have? Let's say we'll define that z is x plus iota y. Okay, I am interested in finding out the argument of z. Okay, so for that purpose, what I'll do, I'll define an angle alpha. Define alpha as tan inverse mod of y by x. Okay, you define tan alpha as tan inverse y by x. Okay, now having defined like this, you figure out that whether this complex number x plus iota y, which is nothing but the ordered pair x comma y, does this lie in the first quadrant, or it lies in the second quadrant, or it lies in the third quadrant, or it lies in the fourth quadrant. In which quadrant does it lies? Okay, now having figured it out, having decided in which quadrant it lies, you define theta, which is the argument of z. You define theta. If the complex number lies in the first quadrant, then theta would be equal to alpha. This is the thumb rule, in fact. If the complex number lies in the second quadrant, theta would be pi minus alpha. If the complex number lies in the third quadrant when it would lie, when x and y both are negative, then theta would be alpha minus pi. And if the complex number lies in the fourth quadrant, that is when x is positive and y is negative, theta would be minus alpha. Am I right, Mayank? Good morning, Mayank. So theta would be minus alpha. Am I right? That's the way we represent it. So can you figure it out? What is minus 1 plus iota root 3? What is its argument? Argument of this complex number. Can somebody tell me? Minus 1 plus iota root 3 argument. What that would be? So for this, quickly we'll define alpha. That is tan inverse. Imaginary part, that is root 3. Real part, that is minus 1. That would be pi by 3 itself. Once I get pi by 3, I decide which quadrant does it lies. X is negative, y is positive. So that is second quadrant itself. So it would be, theta would be pi minus alpha. That is pi minus pi by 3. So that is 2 pi by 3. Am I right? Now, I take the opportunity to tell you, yes, Meenakshi, you're right. Ashit Shikhar, good morning. You're late, Ashit Shikhar. So that's how we get theta. That's how we get argument. I hope this concept is clear to everyone. We move on to the next concept. Polar form of complex number. So, okay, we are talking about polar beer. Yes, that's on the lighter vein. The polar form of a complex number, that is z is equal to mod z. How do you represent z? Z is x plus iota y. Am I right or not? This is x plus iota y. How can you write this x? Given that length of this line segment is r, which is mod z, and this angle is theta, which is the argument. Yes, Satyashikar, no problem. Join us. X is equal to r cos theta, that is mod z cos theta. Am I right or wrong? Tell me. And y would be y. This is the perpendicular and this is the hypotenuse. So it would be mod z sin theta. So if I write this, it would be mod z cos theta plus iota mod z sin theta. So if I take mod z as common, I'll get this. Am I right? Okay. Yes, Chiru, you are also late. Chiru Chiranjeevi. So this is modulus argument form of a complex number. Okay. What would be this? Conjugate if I take, so that would be the reflection in the x-axis. If this is theta, then in the fourth quadrant I told you minus theta is the angle. The cos of minus theta is cos theta itself, and sine of minus theta is minus sine theta. This is what conjugate of z we'll get. Okay, I hope this is understood. Then we come to, let us say, one question we'll do. Okay, or maybe question a little late. I'll come back to This question a little late. Now we talk about that question which we were doing earlier. Anna? Let's open it up. So I had given you this question. Mod z minus 4 is less than mod z minus 1. What is the region I'm talking about? Huh? So you guys have figured out something. Now z minus 4, I can do it in two ways. One, I can do it in the graphical form. Otherwise, I can also do it in the algebraic form. I'll do the square both sides. Both sides are positive, I can do the squaring. And z is x plus iota y. I can write x minus 4 plus iota y and mod square. Here I'll write x minus 2 mod square plus, sorry, square I'll do it later, plus iota y mod square. So what this would be? This would be x minus 4 whole square plus y square, and this side it would be x minus 2 whole square plus y square. Am I right? So what do I get? I get x square gets cancelled, y square gets cancelled, minus 8x plus 16, and here I get minus 4x plus 4. Am I right? So what do I get? 8x goes on this side. I get 4x. Okay. Just a moment, students. Okay. A bit of a problem here. I am getting my power run out. Okay. So 4x and 4 will go on that side. It would be 12. So that means x is greater than 3. X is greater than 3. That means real part of z is greater than 3. That's the region. I hope some students gave me the right answer. Okay. Just a moment, students. Just a moment. Please wait. Okay. So we go on to the next slide. That is this one. Okay. So we represent complex number in three ways. What are those? X plus iota y, polar form, and Euler's form. I'll just express Euler's form. I'll be back in a minute, students. Just hang on. Yes, students, I'm back. I'm sorry, my power went off. Okay. Yes, I'm back, students. So here we are representing Euler's form. Yes, we are representing Euler form of a complex number. What is that? Different way of representing complex number. So this is Cartesian form. Am I right? X plus iota y. And then z is mod z. Mod z can always be written as r. Okay, this is polar form. And then we have mod z r e iota theta. That is nothing but r e iota theta. That is Euler's form. Okay. Is this okay, students? Yes? Chandra? So here we come to the next slide. Okay. What's that? multiplication of two complex numbers. So we are talking of multiplication of two complex numbers in Euler's form. Okay, when z is r e iota theta 1 and w is r2 e iota theta 2, when we multiply these two complex numbers, on multiplication of two complex number, we realize the modulus gets multiplied and the arguments get added, because same base, the powers would be added. Okay, Euler's form seems to be difficult. No, Euler's form is in fact very easy. Yes, Rishabh, it is very easy. Just focus. In fact, what I'm trying to explain you, that r cos theta plus iota sin theta can be expressed as r e iota theta. As simple as that. When you put this thing in power, it becomes very easy. Yes, it makes the questions very easy. Now let's do one question here. Okay, students, what's that? We have, let's say, mod z is equal to mod w. Okay, and argument of z plus argument of w is equal to pi. Then can you tell me z is equal to what in terms of w? The choices are A choice w, B choice minus w, C choice w conjugate, and D choice minus w conjugate. Okay, can somebody answer me? Yes, Deepshika, it is very easy. So anyway, Deepshika, you are getting scared of looking at it? I don't think so. You shouldn't be. Okay, Euler was one of the greatest scientists. Tarun, you are giving me C as your answer. Okay. So students, Tarun C, Rishabh minus W. Okay, B you are giving me. Anyone else who is giving me an answer? So we have mod Z is equal to mod W. Okay. Let's say argument of Z is theta and argument of W is alpha. This is theta 1 and this is theta 2. Okay. So we have theta 1 plus theta 2 as pi. Okay. Chiranjeevi C, Jatin D. Okay, somebody dares to say D. Okay, let's see. Deepshika C you are giving me. So what do we have? I want to express Z in terms of W. Can I write theta 1 as pi minus theta 2? Can I write like this? So by the way, what is Z? Z is R1 e iota R1 e iota theta and e iota theta 1, sorry, and Z2 is R1 only because their modulus are same. W. Just a moment, students. Okay, I'll write it again. So Z, what is Z given as? Tell me. Z is R, that is its modulus, e iota theta 1. That is the argument of Z. And W, the modulus is same, R e iota theta 2. Am I right? This is how Z and W I have represented. Now listen, theta 1 I replace by pi minus theta 2. So I'll write Z as R e iota. Instead of theta 1, I'll write pi minus theta 2. Am I right? So what is that? That would be R e iota pi into e minus iota theta 2. Am I right? Now, e iota pi. E iota pi would be what? E iota pi would be cos pi plus iota sin pi. Am I right? Now, cos pi plus iota sin pi, cos pi is minus 1, sin pi is 0. So, e iota pi is minus 1. So, this I replace by minus 1, I get minus r e minus iota theta 2. Am I right? Now, e iota theta 2 is w. So, this implies w conjugate is what? Didn't I tell you that omega w conjugate or z conjugate is just the reflection of z in the x-axis. So w conjugate would be the reflection in the x-axis. So it would be minus iota theta 2. The argument becomes minus theta 2. So this r and e minus iota theta 2 becomes minus w conjugate. So this is our answer, students, minus w conjugate. D part is correct. I think Jatin gave me the right answer. Chandra, yes, D part is the right answer. Very good. Yes, students, I hope you understood. Now we move on. We move on to, now when we divide two complex numbers, when we divide two complex number, theta 1 and theta 2 are subtracted. I mean the arguments get subtracted. That's important. Then we talk about logarithm of a complex number. Log Ez. If I take log both sides, then it would be log z e iota theta. And here I would like to add up iota argument of z, that is iota theta plus 2n pi. 2n pi would come because its periodicity is 2 pi, where n belongs to integers. So this would be it. So log does not have one value, it's a multifunction. Okay? Ayush, I would request you to replay the offline version of the video. So please see that. Right now I will move forward. Okay? Then properties of argument of a complex number. So we look at this. We have argument of z1, z2. When two complex numbers are multiplied, then their argument is, thank you Ayush, we have argument of z1 plus argument of z2 plus 2k pi, where k is an integer. Okay? Then if we divide two complex number and we are calculating its argument, because this is a complex number itself, it has argument z1 minus argument z2. Okay? Yes, students, I hope you got this. Then we have another property, argument of z upon argument of z conjugate, that is 2 argument plus 2k pi. Okay? Argument of z raised to power n is n into argument of z plus 2k pi. Argument of z conjugate, this is what I did in the last question. I use argument of z conjugate as minus theta. So that is what here it is written as. Argument of z conjugate is minus argument z. Okay? I hope this is okay. Value of k should be chosen in such a way that argument lies between minus pi and pi. That's what I told you, that this argument of z, here it means principal argument. Okay? So then we come to the next slide. That is this one. Okay, de Moivre's theorem. Let's start. Jatin Raj, I explained you the previous line that for the principal argument to find, we should have theta in such a way that it should lie between minus pi and pi. Okay, minus pi not inclusive and pi inclusive. Okay, that's when we get argument of a complex number. I mean amplitude we get, or principal argument. That's one and the same thing. So we go on with the de Moivre's theorem. Okay, what does it say? If n belongs to integers, hello, please listen. Yes, theta belongs to real number, iota is this obviously, then cos theta plus iota sin theta raised to power n is cos n theta plus iota sin n theta. Okay, yes students, you understood? So if you have understood this, then you answer me one question. Okay, I'll take on this question after. Yeah, this question I can ask you. That let us say x1 is just a moment, students. Just a moment. Yes, suppose x is xr XR is cos pi upon 2 raised to power r plus iota sine pi upon 2 raised to power r. Okay, this is what. Yes, Ayush, thank you. Yes, it is interesting. I agree. Suppose XR is this complex number. Okay, so the modulus is 1 and the argument is pi upon 2r. So if you write x1, you'll get pi by 2. If you write x2, you'll get pi by 2 square and so on. You are supposed to find for me what is limit r tends to infinity, x1 into x2 into x3 and so on xr. Okay, you need to tell me what is this limit equal to. Okay, students, come on, fast. Yes, thank you, Rekha. Thank you, Rekha Rustagi, for your appreciation. Can you explain me this question? Can you solve this? Chiru Chiranjeevi, you get 1 as your answer. Okay, pretty fast, man. So, students, here I'll give you the power of Euler's form. Can't I write XR as E iota pi upon 2 raised to power r? Can I write like this? Okay. So what it would be? It would be, yes, Chiranjeevi, Tarun, x1 would be E iota pi by 2. Am I right? x2 would be E iota pi by 2 square. x3 would be E iota pi by 2 cube. Hana? This way I'll keep on going. So it's a infinite GP. So how would I write? I'll write E iota pi would be common and I'll have 1 by 2 plus 1 by 2 square. The powers would add up 1 by 2 cube and so on infinitely. Hana? Am I right? Ankita Yadav 1, Jatin Raj 1, Sanskruti Mishra 1, Ashit Shikhar 1, Harsha 1. Okay, let's see. E iota pi, and I get the sum of an infinite GP. Anybody who remembers sum of infinite GP? A, first term upon 1 minus common ratio. That's the sum to infinite GP. Here what it will make? Half. That's the first term upon 1 minus common ratio is also half. So it is E iota pi by 2. Am I right? Sorry, pi by 2 nahi, pi only. E iota pi. E iota pi. Half upon half will become 1. So E iota pi is what? Cos pi plus iota sin pi. Am I right? Now sin pi is 0, cos pi is minus 1. So minus 1 is the right answer, students. Just check it. Minus 1. Yes, Ayush, Chandra. Okay, minus 1 is the right answer. I hope everybody understood it. So this was the use of Euler's form. De Moivre's theorem, we'll make use of it in another question. Okay. So students, I hope you understood. Can I move forward? Hello. Can I go ahead? Yes. We have De Moivre's theorem second statement as well. What is that? If theta 1, theta 2, theta 3, theta n, etc. I mean, this is not another way of representing it. This is just another way of representing the first form. De Moivre's theorem, we have one more theorem. Okay. Yes, Tarun, lot of concepts are left still. I'll see whatever I can do in this half an hour, that I'll do. Other concepts I'll take in the quadratic equation. Okay. Coordinate geometry of complex numbers left. Rotation of complex number is left. Okay, we go to the next slide. So here we see cos theta minus iota sin theta raised to power n. This is application of De Moivre's theorem only. Okay. 2 raised to power 0 I didn't use in the first term. No, it was 2 raised to power r. R started from 1. It was not R didn't start from 0. R started from 1, Sanskruti. Okay. So if we have sin theta plus iota cos theta raised to power n, I'll have to multiply and divide by multiply and divide by iota. This way I get iota raised to power n and cos n theta minus iota sin n theta. Similarly here I'll multiply divide by n. So this is what I'll get. I mean, this is not required to be remembered, but it is okay just to understand. So if we have sin theta plus iota cos theta, you will multiply inside the bracket by iota and divide by iota, and that's how you get it. Okay. Sanskruti, R, it starts from 1, not 2. So pi by 2 it starts from. Okay. R belongs to n. You are right only, Risha. So we come to cube root of unity. Okay. Cube roots of unity. Yeah. Thank you, Chiru. Thanks for your appreciation. The cube roots of unity. What we are saying when we say unity, we mean 1. The cube roots of unity, what we are expressing, we are having x is equal to 1, cube root of 1. Okay. So we cube both sides, we get x cube is equal to 1. Am I right? Now x cube minus 1 is equal to 0. I can factorize it. It would be x minus 1 into x square plus x plus 1 is equal to 0. Am I right? So what are the roots I am getting? I am getting x minus 1 equal to 0, that's x equal to 1, or I'll get x square plus x plus 1 as 0. This on solving by, yeah, we'll discuss the maximum value sums as well, Chiru. So when I solve this, I get x as by b square minus 4ac method I'll solve minus 1 plus iota root 3 by 2 and under root minus 1 I'll write it as iota. And the other root would be minus 1 minus iota root 3 by 2. Okay. This is something, the first value minus 1 plus iota root 3, this is known as omega. If I square it, then I get this value, this is omega squared. Okay. 1 omega and omega squared. These are the cube roots of unity. Now if I express in modulus argument form, then 1 is this 1 comma 0. Omega would be cos 2 pi by 3 plus iota sine 2 pi by 3. This is modulus argument form of omega. Students, please remember it. Whenever you come across this is omega. And cos omega, that omega square modulus argument form is 4 pi by 3 plus iota sine. So if we convert it into modulus argument form, we'll get this 4 pi by 3. So if I plot it on an Argand diagram, that is imaginary axis and real axis, then one is this. Omega would be a complex number making an angle of 2 pi by 3 with positive direction of x-axis. Further 2 pi by 3 would make it to omega square. And this left out would also be 2 pi by 3. I hope you realize that these are the ends of the, these are the vertices of an equilateral triangle. This is omega square, this is omega, this is 1. So cube roots of unity when plotted on an Argand diagram actually represent the vertices of an equilateral triangle, and they all lie on a unit radii circle. You can see it lies on the circumference of the unit radii circle. The radius is 1 only. Okay. Now we have certain relation between cube roots of unity. What is that? First of all, omega satisfies this equation. Is this right or wrong? The first is 1 plus omega squared, that's 0. Second, omega is the cube root of unity. Omega satisfies this equation as well. So we have omega cube is equal to 1. Okay. Yes, Deepshika, what happened? So here we learned about little bit of omega. We can do one question here. So can somebody tell me what is the value of 1 plus omega minus omega square raised to power 7? What is this equal to? Can somebody answer me? Yes, tell me. Yes, students. The choices are 128 omega, minus 128 omega, 128 omega square and minus 128 omega square. No, excuse me, 1 and minus 1 it can't be, Chiru. How it is minus 101? So you see 1 plus omega square, that is 0. So what do I get 1 plus omega as? It is minus omega square. So I replace it by minus omega square, that is 7. So what do I get? Minus 2 omega square raised to power 7. So that is minus 128 omega raised to power 14. Okay? Yes, that's right. Omega raised to power 14. How do we solve omega raised to power 14? We divide it by 3, whatever is the power, 14. So 3 4 are 12. Omega square is left. That whatever is the remainder, we write it here. So minus 128 omega square is the answer. Is it okay, students? Yes. Is it okay? Are we going fine? Hello. Yes, students. Then we talk about nth roots of unity. Hana? So here I like to explain I would like to explain you the De Moivre's theorem second part. है ना? What is that? If second part I am explaining De Moivre's theorem, so please write it down. This theorem is also very important. Second part of De Moivre's theorem. Please note it down, students. Sir, can you take like chemistry class? I didn't get you. Chemistry class is more interesting. Might be that teacher is taking the chapter in a different way. Cos theta plus sin theta raised to power 1 by n, where n is again an integer. Okay? Okay, Rishabh, full josh. That's great. So this is equal to cos 2 pi k plus theta by n plus iota sine 2 pi k plus theta by n, where k ranges from 0, 1, 2, 3 and so on till n minus 1. That means if we are finding the nth root, okay, if we find the nth root of a complex number, this will give me n values. One by one, I'll put k is equal to 0, k is equal to 1, k is equal to 2, k is equal to 3 and so on. Okay, that's how we get these values. Dr. Gurinder Singh Kang. Hi, new student. Good morning. Please join us. We are doing De Moivre's theorem second part. Thank you, Rekha. So, whenever we are taking nth root of unity, nth root of unity means 1 raised to power 1 by n. How do I go about it? Can I represent 1 in modulus argument form? Modulus is 1 only, and 1 when I express, it is on the real axis. So the angle which it makes with the real axis is 0. That would be cos 0 plus iota sine 0 raised to power 1 by n. Am I right? Sir, 2 pi k क्यों आता है? I mean, this is the way it is represented. This gives me the value. This is De Moivre's theorem. Its proof is beyond our scope of understanding. Its proof is not there in our course. Okay. So if I write like this, I'll get, using this formula, I'll get cos 2 pi k plus 0 upon n plus iota sine 2 pi k, theta is 0 only, upon n. This is what I'll get, है ना? Yes. Now I'll put the values of k 1 by 1, 0, 1, 2, 3, 4. So when I put k is equal to 0, what do I get? Cos 0 plus iota sine 0. Okay, that's 1 only. Then I put k is equal to 1. When I put k is equal to 1, what do I get? I get cos 2 pi by n plus iota sine 2 pi by n. That is e iota 2 pi by n. That is the first nth root of unity. Then I put k is equal to 2. What do I get? I get cos 4 pi by n plus iota sine 4 pi by n. Okay, that is E iota 4 pi by n. Okay, Chandra, shall I tell it fast? Okay, k is equal to 3. So I'll have cos 6 pi by n plus iota sine 6 pi by n. That is E iota 6 pi by n. I hope you understand. This way I'll keep on going till k is equal to n minus 1. So what do I get? Nth roots of unity. Let's say this is 1. Let me call this nth root of unity as alpha 1. This as alpha 2. This as alpha 3 and so on. Till how many I'll have? I'll have till alpha n minus 1. Because whatever is k, I'm getting here as the suffix. Okay? Yes, Rekha? Speed is okay? Yeah? So we have, these are the nth roots of unity. Okay? We'll learn about these properties, their properties. And we'll come back to this slide once again. So what are the properties of nth roots of unity? Number one, they are in GP. They are in GP. That means 1 alpha 1, the second one would be alpha 1 squared, third one would be alpha 1 whole raised to power 3, then alpha 1 whole raised to power 4 and so on. They are in GP. Okay, with the common ratio as alpha 1, that is E iota 2 pi by n. That is a common ratio. Common ratio. Okay. So that's what I wanted to depict here. If I go to the previous slide once again, I find, sorry, not this one, this one. Okay, what I find that it is E iota 2 pi by n, it is E iota 4 pi by n, it is E iota 6 pi by n. So what do we find? The difference of E iota 2 pi by n. So it's a GP. है ना? If I do the square of this, I'll get this. If I do cube of this, I'll get this. So this is alpha 1 whole square, this is alpha 1 whole cube and so on. I hope. Ayush, we'll talk about the engineering colleges later on. Huh? Right now, this is the platform for understanding the concepts. Okay? And no worries, you'll get a top NIT. Okay, Anupam Rai, you got it? Then, second part. As these are nth root of unity, they are located at the vertices of a regular n-sided polygon. You see, we start from 1, 2 pi by n, this is alpha 1 I mean, this is alpha square, again 2 pi by n, 4 pi by n is the angle which it is making. So this is A2. This way we'll make a regular polygon inside a unit radii circle. Okay, so what do I say? I mean that the points represented by the nth roots of unity are located at the vertices of a regular polygon of n sides inscribed in a unit circle having center at origin. One vertex being on positive real axis. Okay, now let me write the properties now. Then what would be the sum of the nth roots? What would be the sum of nth roots of unity? So we realize 1 alpha 1, I can write it 1 alpha 1 plus alpha 2 and so on alpha n minus 1. The sum of nth root is, I'll give you a general formula for this. 1 raised to power p, alpha 1 raised to power p, alpha 2 raised to power p and alpha raised to power n minus 1 p. This is equal to 0 if p is not an integral multiple of n. If p is not an integral multiple of n. Okay. Like for example, when I was talking of 1 plus alpha 2, alpha n minus 1, that would be 0 because it is not an integral multiple of n. And it is equal to n if p is an integral multiple of n, is an integral multiple of n. Okay. I hope you understand. Now third is we have 1 minus alpha 1, 1 minus alpha 2, and so on, 1 minus alpha n minus 1. This was a question in 1985 of 3 marks. Once it was asked in IIT when it was JEE advanced paper in subjective. This was asked to be proved. So this equal to n. Okay. Then fourth one is 1 plus alpha 1, 1 plus alpha 2, and so on, 1 plus alpha n minus 1. This is equal to integral multiple means like 3n, 4n, 5n. I mean, suppose we are finding out the sixth root, then multiples of 6 would be called as integral multiple of p. Okay. Integral multiples means integer into that number itself. So that's equal to 0 if n is even and 1 if n is odd. Okay, students. And then we have the last property as the product of these roots, nth roots of unity, that is minus 1 raised to power n plus 1. Okay. So if n is odd, it is 1. If it is even, then it is minus 1. Okay. Non-fractional, you say. Yeah, you're right only. So this way we have done nth roots of unity. Then let us talk about vector representation of a complex number. Okay. So we realize a vector can be represented as an ordered pair on the Argand diagram. So we have the direction as well as magnitude of a complex number. So we can always treat complex number as a vector. Am I right? Then we talk about rotation of a complex number. Now we come to the zenith of complex numbers, that is rotation. Okay. So first of all, you have to, I'll explain you in two ways. Meenakshi, I hope you understood. Okay. N minus 1 shayad. Anupama, what you were saying? Now here, listen. Rotation of complex number. I explained you rotation of a complex number. That is Koni's rotation method. Koni's rotation method. I'll explain you in two ways. Okay. One. Suppose I'm talking about this complex number Z1 and this is origin, the vertex, and this is complex number Z2. Is there some way I can represent the angle between them? Let's say the angle between them is alpha. How can I represent alpha? Can somebody tell me? So if we realize that this is x-axis, let us say. So this angle would be what? Tell me. This is the argument of Z2. Let's say this is theta 2. This angle is what? This angle is argument of Z1. Let us say this is theta 1. Am I right? N minus 1 you say or n plus 1 you say. It is both same thing, Anupama Rai. That same thing. So this angle is theta 2 and this angle is theta 1. So can't you see that theta 2 minus theta 1 is alpha? Am I right? Now, how can you get theta 2 minus theta 1? If you realize that Z1 can be written as whatever is mod Z1, that is R e iota theta 1, and Z2 you can write it as R2, that is its modulus e iota theta 2. What should I do with these two complex numbers so that theta 2 minus theta 1 comes? Don't you realize if I do Z2 by Z1, what do I get? R2 by R1 upon e iota theta 2 minus theta 1. So I should write argument theta Z2 upon Z1. That would be nothing but argument Z2 minus argument Z1. That is nothing but theta 2 minus theta 1, that is alpha. That's how we represent the angle between two vectors. I hope you understand. Yes, rotation is there. Hello, rotation is there, Deepshika. Why you are showing it's not a JEE Main syllabus? Yes, you should be on the safer side. There are a lot of questions on rotation, I'll tell you. For example, one question was one question was when the midpoint of a rhombus was given and one of the vertex of the rhombus was given, and the relation between the diagonals was given. One diagonal of a rhombus was twice the diagonal of twice the other diagonal. Then the rest of the three vertices were being asked. We have like this, okay? So when so you understand this. So now the question is how rotation comes into picture. The rotation point comes into picture. Anupma Rai, thoda samajh mein aaya. I hope this is okay. This is how we represent the angle between the vectors. Okay. Now let us look at the rotation point here now. I'll go till rotation today. Coordinate geometry of complex number I'll deal it tomorrow with quadratic equation. Okay, students? Coordinate geometry of complex numbers is only left. That's a 15-20 minutes topic that I'll take tomorrow with quadratic equations. Students, tomorrow I'm going to take quadratic equations. So here you have, let's say the question in rotation is, let's say this is Z1. Okay, this vector is Z1. This is origin. I have been given Z1 and I have been asked to rotate it by an angle alpha anti-clockwise. So this angle is also given. And I want to rotate it and I want to increase the modulus by twice its size. So if this is R, I want this to be 2R. So what is the resulting complex number is my question. That's what the question comes out like. Okay? Yes, Ashmit, thank you. Thanks for your appreciation. So this complex number I want to find, let us say this complex number is Z2. So Z2 I need to find. So what do I have? I have alpha, I have Z1, I have the modulus of Z2, that is 2R. So just consider this vector Z2 by Z1. Just consider this expression. Okay, Z2 by Z1 would be modulus of Z2, modulus of Z1 into E iota alpha. This is what it is. Z2 is 2R E iota theta 2 upon Z1, that is R E iota theta 1. So how can I write this? I can write this as 2R upon R E iota theta 2 minus theta 1. And just now I explained you that this theta 2 minus theta 1 is alpha. So that's how I have written this. I hope this is okay. So Z2 by Z1 fetches me mod of Z2. Mod of Z2 is what? 2R. Mod of Z1 is what? R E iota alpha. RR goes. So Z2 I'm interested in finding, that is Z1 into 2 into E iota alpha. That's what I get as my answer. Alpha is known, Z1 is known, so Z2 is calculated. I hope you understand. Yes, R we are cancelling. Yes, good. So what is the formula? What the formula comes? Formula is Z2, Koni's rotation method, formula number 1. Z2 by Z1 is mod of Z2 mod of Z1 E iota alpha, where alpha is the angle between Z2 and Z1. So in other words, Z2 is to be calculated, that is Z1 into Z2 by mod of Z1 E iota alpha. Then a slight change will make you understand Koni's rotation method part 2. So let's go on to that and then we'll do 1 or 2 questions based on this. So distance formula I'll take it later, but here I take this. Okay. So you see, if we have instead of origin, I'm rotating Z1 with respect to origin. Suppose this is Z1. I want to rotate it with respect to Z3. Okay, that's another complex number. I want to rotate it pivoting on Z3. And then I want to rotate it to get Z2. So let's say this length Z1 minus Z3 is given. Let's say this is R. Yeah, 6 minutes are there. I know, we'll do one question more. Z2 minus Z3, this is, let us say 2R. Let us say it is 2R. This length is 2R. Z1 is known, Z3 is known, and I want to rotate by Z3 by an angle alpha. Z2 is not known. So how do I get Z2? That means I'm rotating Z1 instead of with respect to origin, I'm rotating it with respect to Z3. Anupma Rai? Yes, very good. So I'll make use of shifting of the origin. This point I'll make it as origin, and this point I'll make it as Z1 minus Z3. Similarly, here it would be Z2 minus Z3. So I'll change the whole scenario. This I'll make it as origin, shifting of origin, and this point I'll make it as Z1 minus Z3. And this point I'll make it as Z2 minus Z3. That's shifting of origin, or you may say writing it in terms of position vector. The position vector of head minus position vector of tail is position vector of head minus tail. So you completely change the vector. You can write now head as Z1 minus Z3 and the tail is origin. And this angle remains same, that is alpha. And this is mod of Z1 minus Z3, that is R, which I have represented. This is 2R. 2R, I mean, I want to give you the ratio of these two. That's what it is. And this is mod Z2 minus Z3. Am I right? Now, I'm interested in Z2. So how do I get? I'll write Z2 minus Z3 upon Z1 minus Z3. That would be equal to mod of Z2 minus Z3 upon mod of Z1 minus Z3 into E iota alpha. I hope you understand this. Tarun, you are going? Okay. So what do we get Z2 as? We get Z2 as Z3 plus Z1 minus Z3 into Z2 minus Z3 mod upon Z1 minus Z3 mod E iota alpha. I hope this is understood by everyone. I hope this is understood, students. So, this is it. This is what is all about Koni's rotation method. That's how we rotate and obtain a new complex number. So, once this is understood, I can take up few questions tomorrow only. Okay. Also make college review video. Okay, I'll do that. Yes, Anupma Rai. I'll do that. Okay, students, let's take leave today. So I have not done coordinate geometry of complex number. Thank you, Rupam. Thank you, Ayush. So we have not done complex number of coordinate geometry of complex number. That we'll do tomorrow with quadratic equation. Okay. Yes, Sanjay. Thank you. You also have a nice day. A great day ahead. Bless you, students. We can stop. Okay. So bye bye, students. Have a great day ahead.